Hi, boys and girls. So I'm going to do topic 14, the test review. We have 15 questions, okay? As you can see, I have anchor charts next to most of the questions to help us out. So I'm going to start with number 1. And please excuse the blurriness of it. Number 1 says angle, okay, remember this sign means angle. Angle EFG has a measure of 33 degrees. Okay, then it says angle GFH has a measure of 47 degrees. Then it's asking, which is the measure of the angles when they are added together to form EFH? Okay. So first, let me examine my angles. Okay, if I examine my angles, I can notice that 33 degrees is an acute angle, and 47 degrees is also an acute angle, okay? Remember, anything below 90 is an acute angle, okay? So I'm going to put here acute, okay, and I'm going to put here acute, okay? And then it says, the question says, which is the measure of the angle when they are added together to form EFH, okay? So it just tells me here already added, okay? So I'm going to add my angles. I have 33 plus 47. If I add them, 7, 8, 9, 10. Carry my 1, drop my 0. 3 plus 1 is 4. 4 plus 4 is 8. So I get 80 degrees. That would be for angle EFH. Okay, so that is B. So for this one, since they didn't give me a picture, they did tell me my keyword added together, okay, to form EFH. Okay, number 2 says, Missy used 4 sticks to create a 2-dimensional figure with 2 sets of parallel sides and no right angles. My question's asking which could be her figure. Okay, so she used 4 sticks. Her 4 sticks just mean her 4 sides. Okay, and it says with 2 sets of parallel lines. So that just means 2 pairs of parallel sides and no right angles. So remember, a right angle looks like an L, like a perfect L, and it measures 90 degrees, okay? So I'm trying to find a shape that has 2 pairs of parallel sides and that has no right angles. So it does not have an angle that looks like this, okay? So let's go and look at A. So for A, I'm going to first see if it has 2 pairs of parallel sides, okay? I have one right here. Okay, let me do this with my pencil. I have one right here, and I have one another one right here. That's 1 pair of parallel sides. I have one right here and one right here. That's 2 pairs of parallel sides, okay? So it goes with that. Now I have to make sure that it has no right angles, okay? So let me erase this so I can look better at it. So I'm going to put a check mark off because it has 2 parallel sides. Now, I can form a square here, I can form a square here, I can form a square here, and I can form a square here, okay? And this is a perfect L, 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 okay? So these definitely, there are 4 right angles in a square. So this, I have an X, this cannot be my answer. I need to have 2 check marks, okay? So I'm going to do B now. So for B, let me see if it has 2 pairs of parallel sides. Okay, this top is parallel to the bottom. This side is parallel to this side. So I'm going to put a check mark that matches. Okay, Let me erase this just so I can look at it better. Now let me see if it has let me see if it has right angles, okay? So because this is slightly slanted, there are no right angles in this shape. Because it's slightly slanted, there's no right angles. So I'm going to put a check mark. So B could possibly be my answer, okay? So now let me do C. Okay. For C, let me check to see if there's any parallel sides, okay? This side and this side will eventually cross. They will intersect, okay? This side will intersect with this side, and this side will intersect with this side. So definitely already, I do not have two pairs of parallel sides. So I'm going to put an X, so definitely this cannot be my answer, okay? So now I'm going to do D. D is not coming out so good on my iPad, but D, as you can see, let me do parallel sides. This side is parallel to this side, and this side is parallel to this side. So I'm going to put a check mark. I have two parallel sides, okay? So I'm going to erase it so I can look at it better. So now let me see if I have four right corners, okay? I have a perfect corner here, and I have a perfect corner here. So I definitely have right angles in this one. So I'm going to put an X. This one cannot be my answer. My answer is B, okay? Okay. So that's how you do number 2. Number 3 says, which geometric term best describes a computer screen? Okay, so a computer screen is very flat, okay? So I'm just going to draw that. I'm trying to do my best to draw a computer. And then I have my keyboard. Okay, so this is my computer screen right here. Okay, like I said, computer screen is flat. So I need to see which geometric term matches that. I have a point, I have a ray, I have a line, I have a plane. So the best thing to do is to draw what each one is. So a point, I have my anchor chart here. A point is just a dot, like a period. So I'm going to put that here. This is a point. Okay. A ray, let's see, I have it here. A ray looks like this. It has a little period, and then it has an arrow. So that's what I'm going to draw. Okay. So a little dot and an arrow. Okay. A line looks like this. It has two arrows on both ends. Okay, so I'm going to draw that, an arrow here and an arrow here. Okay. And a plane, so I have it here. A plane looks like this. It's just, it says an endless flat surface, okay? So it just looks like this. So that's what I'm going to draw. Okay? So now I need to look to see which term and which picture best matches the computer screen, okay? So definitely, I'm going to take off my silly answers. It cannot be a point, okay? It cannot. Like, a little dot does not look like a computer. It doesn't. So it can't be A, okay? A ray, this arrow here, this endpoint with an arrow, this does not look like a computer screen, okay? For C, I have a line. This arrow here does not look like a computer screen, okay? And D, I have a plane. So this could potentially look like a computer screen, and it says the definition, remember, for a plane is an endless flat surface, okay? And a computer screen is flat. So our answer is D, okay? For 13, so that's how you do 3. Whoops. Let me go to 4. My bad. Okay. For 4, it says, which quadrilateral, okay, must have 2 pairs of parallel sides that are all the same length and 4 right angles, okay? So I have some important keywords here. I have quadrilateral, okay? Remember, quadrilateral just means it has 4 sides and 4 corners, okay? And it has to have 2 pairs of parallel sides, okay? Remember what I was talking about if you have 1 pair, it's like 1 pair of shoes. You have 2 shoes. If you have 2 pairs of shoes, you have 4 shoes, okay? Because I know a lot of you guys are getting mixed up on pairs. So I have 2 pairs of parallel lines that are the same length, and I have 4 right angles, okay? Remember, right angle looks like this, a perfect L, and it measures 90 degrees, okay? So now what I'm going to do is I'm going to make a drawing of each shape. I have a square, rhombus, trapezoid, parallelogram. So I'm going to do square. For square, I'm just going to do my best to draw a square. For rhombus, I'm going to do my best. For trapezoid, looks like this. And then parallelogram, let me do that better. Okay, I'm not the best. Okay, so those are my shapes. So now I'm going to see which one matches the description. It has to have 2 parallel sides. So I'm going to go see that right now. Okay, so my square, I have one side here is parallel to this side, okay? This side over here is parallel to this side, okay? I'm going to check mark that off. That matches that. Now I have to see if they're all the same length and have 4 right angles, okay? Definitely, I should know a square has 4 right angles. I can make a corner in each, okay? So this could potentially be, I'm going to put check mark, question mark. This could be my answer. A rhombus. So let's see a rhombus. I have 1 pair right here. They're parallel sides. I have another pair here. They're parallel sides, okay? Now, but does a rhombus have 4 right angles? So because a rhombus is slightly slanted, it does not have 4 right angles. So check mark for 2 pairs of parallel sides, but it does not have 4 right angles. So I'm going to put an X. So this cannot be my answer. Okay. Next is trapezoid. For trapezoid, this top is parallel to the bottom. Okay. But this side is not parallel to this side. Eventually, they will cross. Okay. So for sure, trapezoid does not have 2 pairs of parallel sides. I'm going to put an X. So I know for a fact that cannot be my answer. Next is a parallelogram. So a parallelogram, this top is parallel to this bottom. This side is parallel to this side. So it checks off. It has 2 parallel sides, okay? But a parallelogram, since it's slightly slanted, it does not have 4 right angles. And all of the sides are not the same length, okay? This is longer than this. So I'm going to put an X, okay? So my answer would be A, a square. A square has 2 pairs of parallel sides, and it has 4 right angles, okay? Number 5. Number 5 says, Ben put 5 sticks in the pattern below. Which stick is parallel to stick oh my gosh, I can't even read that. To stick U. Okay? So, let's see. So, I'm looking for stick U. Stick U is right here. Okay? And so, I'm looking to see what line is parallel to that. So, I have my anchor chart here. Parallel lines look like this. A pair of lines that travel in the same direction and are the same distance. So this is parallel lines. It could be that way or it could be going this way. Okay? So let me see which ones look like that. Which ones look like this or like this. Okay? They can either go horizontal or vertical. So my other matching one would be this line right here. Okay? And I'm going to go with C. Okay? So they're both going vertical like this. They are never going to touch each other. Okay? That's how you do 5. Number 6, it says angle XYZ measures 128 degrees. Which type of angle is angle XYZ? So I'm looking for a certain type of angle, okay? So I either have obtuse, acute, right, or straight, okay? So I have my angles right here, okay? And I have them right here, okay? So first of all, let me see, what does an obtuse angle measure? So it says right here, an obtuse angle measures more than 90 degrees. So next to obtuse, I'm going to put more than 90 degrees, okay? Let's see what an acute measures. It says acute measures less than 90 degrees. So I'm going to write that over here. Less than 90 degrees, okay? A right angle, I'm going to go over here. It measures exactly 90 degrees. So I'm going to put that over here. 90 degrees. And a straight angle measures exactly 180 degrees. So I'm going to put that 180. Okay? So now I'm looking for one that measures 128. Okay? So 128. Let's throw out the answers. I know for sure it cannot be. It can't be C because C measures 90. I'm looking for 128. So not this one. Okay? It can't be B because acute is less than 90 and I have way more than 90. So mark that off. Okay? It can't be D because a straight angle is exactly 180 and I'm looking for 128. My only answer left is obtuse. Obtuse measures more than 90. Okay, this is more than 90. So my answer is A. Okay, let's go to number 7. Number 7 says, Angelica's mom cuts a pie into 6 pieces of the same size. What is the angle measure of each piece? Okay, so to make this problem a little bit easier, we're going to draw a pie. Okay, so I'm going to draw a circle. Okay, and I'm going to cut this circle into 6 pieces. So cut it in half. Cut it the other way. Cut it this way. Okay, and then 1, 2, 3, 4, 5. Okay, so that should be 6. Okay, my circle is not perfect. So 1, 2, 3, 4, 5, 6. Okay. So I need to figure out what is the measure of each piece. So this piece or this piece, any piece. I need to figure out what's the measure of each piece. Okay. So this one takes a lot of thinking. If you look at a circle, you know that I have a straight line at half of the circle. Okay. Straight line at half the circle. So I know for a fact that half of my circle, okay, so I'm going to just put this out. Half of my circle I know is going to measure 180 because I have a straight line in the middle. So I know this whole angle here, this whole angle is going to measure 180. So I'm going to label this. This whole angle, okay, all of this is going to measure 180. So if this half measures 180 in a circle, this is my line of symmetry. If this part is 180, that means that this other half is also 180. So I'm going to write that. I'm going to put 180. Okay. So now I want to see, okay, what if I put the two halves together? What does the whole circle make? Okay, so I'm going to do that over here. I'm going to put 180 plus 180, and I'm going to add them. 0 plus 0 is 0. 8 plus 8 is 16. Carry my 1. Drop my 6. 1 plus 1 plus 1 is 3. I get 360. So this whole circle, I'm going to write it here. This whole circle measures 360. Okay? So now I need to know though, okay, well what is just one section of it? What is just one section of the pie? Okay? So to do that, I can do, this was my first step. To do that, I can do 360 divided by 6. Okay? So this is my second step. I'm going to do 360 divided by 6. Remember, we make our box. Okay? We put our 6 on the side, and we ask ourselves, how many times can 6 go into 36? Well, actually, first, how many times can 6 go into 3? Okay? It cannot. 6 is too big. So now I ask myself, how many times can 6 go into 36? 6 times. So I'm going to put 6 on top of my 36. 6 times 6 is 36. 36 minus 36 is 0. Carry my 0. 6. How many times can 6 go into 0? None. So I'm going to put 0. 6 times 0 is 0. 0 minus 0 is 0. Okay? So that means one piece measures 60 degrees. Okay? B is my answer. Okay? Another way you could do that is you can, if you didn't want to divide, you can say, okay, I can multiply 6 by every number and see which one gives me 360, okay? And if you did 60 times 6, well, 0 times 6 is 0. 6 times 6 is 36, okay? And then you could say, okay, since I get the same thing, 36, 36, that means 60 is my answer. You can do it that way too, okay? The important thing to know about this problem is that half a circle measures 180 degrees. So that means the other half is also 180. And if you add those together, you get 360. So that means the whole circle measures 360. Okay. Number 8 says, whose shape has 3 lines of symmetry? Okay, so remember, symmetry, I have my anchor chart here. And let me make this a little bit bigger. Okay, symmetry just means, again, it can be folded on a line to form 2 halves that fit exactly on top of each other. The folded line is called line of symmetry. Okay, so it's like these shapes. For a rectangle, I have 2 lines of symmetry. Okay, for a hexagon, I have 1, 2, 3, 4, 5, 6 lines of symmetry. And then for a shape like this, since it's not equal on both sides, I don't have any lines of symmetry. Okay, so now I'm looking for a shape who has 3 lines of symmetry. Okay, so let's go through each one. Let me make this smaller. So on my anchor chart, I already know a rectangle has 2 lines of symmetry. Okay, so I'm going to draw that. So I can break it in half right here. Let me use this. I can break it in half here, and I can do it again this way. Okay, so A rectangle only has 2 lines. So I'm going to put 2 here. Okay. So for sure, I'm looking for 3. So Scott is not my answer. Okay. So now let me do the triangle on top. Let me do Tina. So first, let's examine the shape. This is a triangle. Okay. And if we notice, this triangle has acute angles. Okay. And if we also notice, this triangle is equal on all the sides. So this is called an equilateral triangle. Okay. So let's see how many times I can do my line of symmetry. I can do one down here. Let me do that again. Okay. I can do one down here. Okay. Because this triangle is equal on all sides, I can do another one right here. And I can do another one right here. Okay. So this one has 3 lines of symmetry. Okay. So now if I go to my square, let me see how many I can do with my square. I can put one going down. I can put one going across. Okay. I can do one going diagonal. And I can do one again going diagonal. So I did 1, 2, 3, 4. So I'm going to put a 4 here. Okay. And this was just a regular square that had all equal sides. My last one, so for sure, I can say Sarah's not it. Okay. Tina might be it. Let me put a question mark, okay? Last one, I have Jake. If I notice, this is a triangle. This side and this side are equal, okay? So because I only have 2 sides equal, this is called an isosceles triangle. So let me see how many times I can do my line of symmetry. Okay. I can only do it 1 time. Because this triangle does not have equal sides, because it only has 2 equal sides, I can only make 1 line of symmetry. So I'm going to put 1. So my answer is not Jake. Okay. That means my only answer left is Tina. Okay. The only reason why I could make 3 lines of symmetry for this triangle is because it's an equilateral triangle. All the sides are equal. That's the only reason why. Okay. Number 9. Number 9 is asking, what is the measure of the angle shown below? Okay. So this is, remember, this is called a protractor. Okay. Remember, a protractor counts by tens. And I have it right here where it says, if the angle points left, use the top numbers. If the angle points right, use the bottom numbers. Okay. So remember, like I said, we count by tens. You count the long, you can't see it here, but you count the long lines. If your arrow here ends up in between 2 long lines, then you count it as a 5. Okay. So this is going to be a little bit hard to do because I can't really see it that well. So I'm going to, since my angle is going like this, I'm going to start over here, okay? And I'm going to count by tens. So 10, 20, 30, 40, 50, 60, 70, okay? You can't really tell, but this would be 80, but it's not there yet. It's not at 80 yet. It's in the middle. So because I'm at 70, it's going to be 75, okay? So my answer is C, okay? This will be better to do when you're doing it on your Google Classroom, okay? It's just because I took a picture of it, so it's very blurry. Okay, let's go to 10. 10 says, which quadrilateral is also a name for all rectangles? Okay, so my keyword quadrilateral, remember quadrilateral is 4 sides, a shape with 4 sides, 4 corners. Okay, so I'm looking for a quadrilateral. Which quadrilateral is also a name for all rectangles. Okay. So let me see if I can see what a rectangle is. So a rectangle has 4 right angles and it is also a parallelogram. Okay. So it says it right here, is also a parallelogram. A rectangle is a parallelogram because it has two parallels, has 2 pairs of parallel sides. So one, whoops. Okay. So it has one here, another here, another here. Okay. Okay. So for sure, it cannot be a trapezoid. Okay. Okay. So, for sure, it can't be a trapezoid. So you're looking for a quadrilateral. It's also a name for all rectangles. Okay. So remember when we were doing our assignment the other day and we had to come up with names for shapes. We had to come up from all the names. Okay. We had to come up with a bunch of different names for one shape. And so all the shapes were also known as a parallelogram. Okay. Because majority of quadrilaterals, except for the trapezoid, but all quadrilaterals will have 2 pairs of parallel sides, okay? So which quadrilateral is also named for all rectangles? Your answer would be a parallelogram. Okay, so because it's a parallelogram, because a square is known as a parallelogram. A rectangle is known as a parallelogram. A rhombus is known as a parallelogram. Okay. 11 says, which is the measure of an angle that cuts off 1/8 of a circle? Okay. So again, I'm dealing with a circle, so I'm going to draw a circle. Okay. Because it's better if you draw what you have instead of just trying to think of it in your mind. Okay. And I have my circle cut into eighths. So I'm going to go in half. I'm going to go across. I'm going to go this way. Okay, that wasn't good. Okay, let me do that again. Okay, so I have my circle, go half, go this way, okay, and go this way. Okay, that's not perfect. Okay, so now if I count them, I have 1, 2, 3, 4. Whoops, forgot to change it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I have my circle. I have my eighths in it. Okay. And it says, what is the measure of an angle that cuts off 1/8? So now I'm just going to highlight 1/8. Okay. This is 1/8. So now when I look at this 1/8 right here, I need to ask myself, okay, I have my answers. I have 90 degrees, 80 degrees, 45 degrees, 30 degrees. So first of all, I know 90 degrees is a right angle. This right here does not look like a right angle. So for sure, it's not A. Okay? Next one, B, I have 80 degrees. 80 degrees is like a little bit less than a right angle. So if this was 80 degrees, it would be a little bit bigger than this. It would be maybe this, okay? Or maybe this. This is way too small to be 80 degrees, okay? Because 90 degrees would be this. So if I had 80, it would be something over here, okay? So it's not 80 degrees. So now I'm left with 45 and 30, okay? So let me look around my angle. My angle's right here, but I know, I can tell right now that I have a right angle right here. Okay, I have a right angle right here. So I know that if I add these two sides up, they would equal 90 degrees because this whole thing right here is a perfect right angle. So I'm going to put that here. I'm going to put this, both of them, if I add them together, if I add these angles together, they're 90 degrees. So now I'm going to think, okay, so then let me go through my answers. I want to know, if I add 45 and 45 together, do I get 90? So 5 plus 5, 10, bring up my 1, drop my 0. 4 plus 4 is 8, plus 1 is 9. Okay, so I do get 90. So this could be 45 degrees. This could be 45 degrees. And together, they would make my right angle, which is 90. Okay, I'm going to put a question mark. Let me try doing it with D. So let's say that both of them are 30. Whoops. Didn't mean to do that. So let's say both of them are 30 degrees. Okay, so let me add that. 30 plus 30. 0 plus 0 is 0. 3 plus 3 is 6. Okay, 60 degrees. Okay, this would not be 60 degrees. Okay, because this right here is a perfect right angle. It would not be 60 degrees. So this is not right. Okay, so my answer would be C. Okay, it makes sense that this would be 45, this would be 45. If I add them together, I get 90, and this right here is a perfect right angle. Okay. For number 12, it says, if the measure of angle SRT is 27 degrees, what is the measure of TRQ? Okay, so I'm going to go find the first thing they give me. SRT, they said, was 27 degrees. So I'm going to put inside of here 27 degrees. Then they're asking me, what is the measure of TRQ? Okay, so I'm going to underline it. TRQ is right here. And I'm going to put a question mark. I don't know. Okay. So now let me look at this angle. I notice that this whole angle right here is a perfect L. And it has a box inside too, which is telling me that this right here, this whole angle is 90 degrees. So I'm going to put this here and I'm going to put whole angle 90 degrees, okay? So if I know the whole angle is 90 degrees and I know that one part is 27, but I am missing another part, I am going to subtract, okay? If you are missing one of the inside angles, you will subtract. So I'm going to do 90 minus 27. Remember, the big number goes on top. I cannot do 0 minus 7. Take away from the 9, it becomes an 8. The 0 becomes a 10. 10 minus 7 is 3. 8 minus 2 is 6. I get 63 degrees, which is C. Okay. If I wanted to check myself, I can say, okay, let's see. 27 plus 63, if I add them, I should get the whole measurement of the angle, which is 90. So let's see. 7 plus 3 is 10. Carry my 1, drop my 0. 6 plus 2 is 8. Plus 1 is 9. So yes, that checks off. My answer is 63 degrees. Okay. And here in my anchor chart, I even have what a right angle looks like. Looks like a perfect L. Okay. Let's go to 13. 13 says line segment AB and line segment CD are perpendicular. What is the measure of each angle their intersection forms? So I have my anchor chart here. Let's look at what perpendicular lines look like. Perpendicular lines are a pair of lines that cross to form right angles. Okay, it looks like this. So I'm going to draw it. Okay. So this is a perpendicular line. It can form 1, 2, 3, 4 right angles. So that means this angle right here is 90 degrees. The other angle, 90 degrees. The other angle, 90 degrees. And the other angle, 90 degrees. Okay? My question's asking me, what is the measure of each angle their intersection forms? So I just put it right here. It's 90 degrees. Okay? Your key word is perpendicular. Perpendicular is the only one that can make perfect right angles. Remember, intersecting makes V's. Okay? Number 14 says, Daniel's teacher asks him to describe the edge of a textbook using a geometric term. Which geometric term should he use? So we're describing the edge of a textbook using a geometric term. Okay? So if we look at our geometric terms they're giving us, we have a ray, a line segment, a plane. So I'm going to draw what each one should look like. Okay? My first one is a ray. It's not on here. Where is it? Here it is. Okay? I have a ray. A ray has an ending point and a line. Okay? So I'm going to draw that. I have my ending point and I have my line. Okay? A line is just looks like a line with 2 arrows. So I have an arrow here. I have an arrow here. My line segment is a part of a line with 2 endpoints. Okay, so I'm going to draw that. I have an endpoint here, my line, endpoint here. And a plane is just a flat surface. So I'm just going to write flat surface. Okay. And I'm going to do my best to draw this. I have a book. And he's trying to describe the edge of the book. Okay. So I'm trying to describe this part here, the edge of the book. So a ray has an ending point, but this arrow is going on and on and on and on and on. Okay. My edge here does not continue to go on and on and on and on. So it cannot be A. Okay. For B is telling me that this line will go on and on and on and on forever for both sides. My edge here does not go on and on and on forever for both sides. So it can't be B. A line segment has an ending point on both sides. Okay. My edge stops at a certain point for the book. So it could be a line segment. Okay. Next, plane, a flat surface. So my edge is at the edge of a book, okay? This is not a flat surface because it's the edge, okay? It's the edge of his textbook, okay? So it cannot be D. A flat surface would be like a chalkboard, an erase board, a computer screen, okay? But the edge is not a flat surface, so it cannot be plane. My only answer is a line segment. Okay. Number 15 says Grace draws a straight angle. Then she draws a ray to divide the angle into smaller angles. If one angle measures 135, what is the measure of the other angle in degrees? Okay. So for this, they're not giving us a picture. And please, when you get a problem like this, don't just say, you know what? I'm so smart, I can do it in my head. Because I know you guys are smart. But please, even I have to write this down. Okay? So, Grace draws a straight line. I'm going to draw my straight line. Okay? And a straight line. A straight angle. Okay? And we should know a straight angle has an exact measurement. Okay, I have it somewhere here. Where is it? Here it is. A straight angle measures exactly 180 degrees. Okay, so before I even do anything else, I'm going to put here, this is 180 degrees. Okay, that's my straight line. Then it says she draws a ray to divide the angle into smaller angles. Okay, so I'm going to draw my ray. And remember, a ray looks like this. I have it in my other problem. Okay, so I'm going to draw my ray. Okay, it has my ending point and then it has an arrow. Okay, so he draws the ray to divide the angle into smaller angles. Okay, so now I have, whoops, let me put my arrows here. Almost forgot. So now I have an angle here and I have an angle here. Okay, it says if one angle measures 135, so I'm just going to pick whatever angle. Okay, I'm going to pick this angle right here. I'm going to say this angle is the one that's 135. Okay, if this angle measures 135, what is the measure of the other angle? So I'm going to put a question mark. I don't know this angle right here. Okay, so remember, if I know my whole angle is 180, I know part of it is 135, but I do not know the other part, I'm going to subtract. Okay, so 180, my bigger number's on top, minus 135. I cannot do 0 minus 5. I take away from the 8. It becomes a 7. The 0 becomes a 10. 10 minus 5 is 5. 7 minus 3 is 4. 1 minus 1 is 0. Okay, so that means the other angle is 45 degrees. Okay, if I want to double check, I can say, okay, 45 plus 135 should give me 180. So let's see, 5 plus 5 is 10. 3 plus 4 is 7, plus 1 is 8. Bring down my 1, I get 180. So my answer is 45 degrees, okay? And I cannot see the numbers here, okay? But just know you have to bubble it in. So this is the review for topic 14, okay? It's very, very, very important that you know your angles, okay? You need to know your quadrilaterals. You need to know your triangles. You need to know your geometric terms, okay? You need to know your parallel lines, intersecting, perpendicular, more geometric terms, okay? It's very, very important that you know all this, okay? You need to know how to read a protractor, so please study it. Look at your anchor charts. Go over the videos. If you have any questions, please let me know.